Hi everyone, in today's lesson we're going to talk about how to multiply and divide rational expressions. When I say the word rational expression, I mean fraction or fractional expressions. So when you learned elementary school, you learned that if we're multiplying, say 1/2 times 3/5, we would multiply the numerators, 1 times 3, we get 3, and then the denominators, 2 times 5, and we get 10. And if we could simplify this answer a little bit more, we would. So we're going to kind of use that same theory here, except we're going to have variables now, not just numbers. So we want to try to factor and simplify anything that we can first. So if we look at example number one has nothing that can be factored, but we can simplify it. So you can simplify across, meaning any top with any bottom. So I can take the 3 and simplify it with the 27, or the 3 and the 5, or vice versa with the 18 and the 5 and the 18 and the 27. So I'm going to show you how we can cross simplify. So what I'm going to do is first look at the 3 and the 27. I can divide those both by 3. So if I divide 3 by 3, I get 1. And if I divide 27 by 3, I get 9. Now, there's no b in the numerator, or in the denominator here, so I can divide this b with one of these b's. So I'm going to cross off one of these b's with this b. And then I'm going to look at the 18 with the 9 because I can cross simplify those. So I know I can divide 18 and 9 both by 9. So 9 divided by 9 is 1. 18 divided by 9 is 2. And now I'm going to take a look at the a squared and the a. I can divide both of them by a, so the a with one of these a's, and I can actually cross off this x with this x. So what I've done here is simplified first, so now I can multiply any top with any bottom. So now let's see what's left over. I have a 2 on top, an a on top, and a 1 from this expression. So if I multiply straight across now, just like I did in this example, 2 times a times 1 is nothing other than 2a. And now on the bottom, what am I left with? 5b times 1. So all I'm left with is 5b. So this would be the final answer. Now we could have gotten that answer the other way. Now the other way would be this: 18 a squared x over 5b squared times 3b over 27ax. So the other way is just go with the rules of multiplication like you've learned in elementary school. Multiply the tops with the tops and the bottoms with the bottoms, and then simplify later. So if you do 18 times 3, and then you multiply a squared x and b together, that would be multiplying the numerators. So type in the calculator 18 times 3, and you'll get 54. And then we have a squared x and b all over. Now if you type into the calculator 5 times 27, you'll get 135. And in order, I guess we'll do a, x, and b squared. So now to simplify something like this, we're going to simplify 54 and 135. Now that's something you're probably going to need the calculator for, so type in 54 over 135 and then hit math, enter, enter. And you should get 2 over 5, 2/5. Now we can see that this x divided by that x cancels to 1. A squared and this a cancel, so we just have an a on top. This b canceled with one of these b squareds, so there's a b on the bottom. So that finalizes our answer that we have an a and a b on the top and then on the bottom. So just know that you can multiply things, either multiply first and then simplify, or cross simplify first and then multiply. Now you're going to find with the more examples that we do that this example is actually going to be more helpful. So let's show you why. So in example number 2, it looks as though I can factor some of these two pieces. So I'm actually going to do that first because it's going to help me. If you look at the 2x plus 6, you see that I could take a GCF out of 2, and I'm left with x plus 3. So I'm going to cross that off and write its factored form. Now, same concept here. On the bottom, I have 6x plus 18. I can actually take out a GCF of 6, and I'm left with x plus 3. So realistically, all the stuff that I'm left with on top is 2x plus 3, the 3x squared, but I see here that I could take this 3x squared and the x squared and actually cross simplify them. So what that means is I could take out an x squared and an x squared. And I even see here that I could divide a 3 and a 6. So 3 and 6 both go in 3 times. So 3 divided by 3 is 1. 6 divided by 3 is 2. So now if you see, the only thing you're left with on the top is 2x plus 3. And the only thing you're left with on the bottom is a 2x plus 3. Now all this stuff cancels to 1. That's actually a nice example where everything canceled out. Okay, let's try a little bit harder of an example. Example number 3. It looks as though that I can factor all 3 of these pieces. So let's see what I get when I do that. I'm going to start with this one, a squared minus b squared. I know that that is dots, so I'm going to start by factoring that into a plus b and a minus b. Okay, now if you look on this numerator here, it looks as though I can only factor out an a, or an a squared rather. So a squared, and I'm left with a minus b. Now here I can cross off, I can factor out a b squared, and I'm left with a plus b. So this one might be a little bit harder for us all to see, so I think I'm going to show you an alternative way to write this. So we could write this as one big parentheses. So we're literally multiplying all of these pieces together. So I'm going to put the a squared and the b squared first, then the a minus b and the a plus b. And then on the bottom, I'm left with the a squared, b to the third, and then a plus b, a minus b. So all I did was just say, okay, this piece, this piece, this piece, and this piece are all being multiplied together on the top. This piece, and this piece all being multiplied together on the bottom. So now I'm going to play the game of crossing everything out, or things that can be. So a minus b and a minus b cancel to 1. A plus b and a plus b cancel to 1. A squareds cancel to 1. And the b squared, I can cancel 2 of these with 2 of those. So I have 1b left over. Now where that 1b is on the bottom. And the only thing left on top is 1. So that's the final answer there. Okay, I'd like you to look at this word problem now, number 4. It says, if the length of a rectangular garden is represented by this, and its width is represented by this, which expression represents the area of a garden? Well, it tells you that it's a rectangular garden. So we have a rectangular garden with length. Oops. And a width. So if we recall, the area formula for a rectangle is length times width. So in the same sentence with multiplying, I'd like to see if you could try this one on your own for homework. I'd like to see if you can multiply the length and the width together and simplify it just like we did those examples before. All right, let's move on to dividing. Okay, so dividing is relatively the same thing as multiplying, except for dividing we always have to remember to keep, change, flip. Or in other words, understand that dividing is the same thing as multiplying by the reciprocal. Okay, so the first example, we can't do anything before we keep, change, flip. So we're going to keep the first fraction. So you're going to keep the 3 over 7, or 3k over 7. We change the division to a multiplication, and then we flip the last fraction. So it becomes 14 over 6k squared. So I'm going to cross simplify. So I see a 14 and a 7 across from each other, both of which are divisible by 7. So 7 divided by 7 is 1, and 14 divided by 7 is 2. Now I see a 3 and a 6, both of which are divisible by 3. So 3 divided by 3 is 1, 6 divided by 3 is 2. And I also see that I have a k here and 2 k's on the bottom. So I'm going to cross off one of the k's with one of the k's here. And I even notice that I have now 2 divided by 2, which cancel to 1. So the only thing that's left on the top to multiply is 1 times 1, which is 1, and the denominator, which is 1 times 1 times k, which is just k. Okay? Now let's try another division problem, which is a little bit more challenging because there are pieces that we can factor. So the first thing we're going to do is we're going to keep the first parenthesis, or first fraction, change the division to multiplication, and flip the last. So we keep, change, and flip. Alright, so now we're going to do the same rules that we've learned before. We're going to multiply. So if it helps to write it like with that long fraction bar, we can. So I'm going to write this as 3y times 2y minus 3, and y to the third, 3 minus 2y. So we notice that these two terms right here are very similar. And we actually can divide them, but since they're opposites and subtraction is not commutative, they divide to a -1. And the -1 always goes on top. Always. Okay? And now I have a y and a y to the third, so I can cross off this y with one of those on the bottom, so there's y squared on the bottom. So the only thing left on the top is 3 and a -1, so -3. And on the bottom, I'm just left with y squared. Final answer. Okay, let's see if we can try example number 3. So same concept, we're going to keep, change, and flip. So we're going to keep, change, and flip. So we're going to keep the x squared minus 25 over x squared plus 7x, change, and flip. Okay, so now let's start factoring. The first piece that draws my attention is the first one here, which is dots, x plus 5, x minus 5. Then I see here I could factor out an x using GCF. Then I see two trinomials that I can factor using add multiply. So we're looking for factors of 10 that add to 7. X plus 5 and x plus 2. And the factors of 14 that add to 9 are x plus 7 and x plus 2. So now I'm just going to play the game of what can I cross off. So x plus 5 and x plus 5. Remember, you can cross off any top with any bottom that's the same. X plus 7 and x plus 7, x plus 2 and x minus 2. So the only thing I'm left with on top is x, and the only thing I'm left with on the bottom, the only thing I'm left with on top is x minus 5, and the only thing I'm left with on the bottom is x. Final answer. Now, be careful, you cannot cross these off, because remember, it means x over x minus 5 over x. So it's really 1 minus 5 over x, not just -5. Okay. So now let's read example number 4. If this expression represents the area of a rectangle and this expression represents the length, find the rational expression that represents the width. So remember, we just did it before, that the area of a rectangle is length times width. We're given the area and we're given the length, and we want to solve for the width. So all we're going to have to do is divide by the length to find the width. So the width is the area divided by the length. So try to see if you could do number 4 for homework again, and we'll go over that in class tomorrow. All right, one last example. Okay, sometimes I could give you multiplication and division in the same problem. So what happens here is if I have multiplication between these two, but then division between these two, I'm going to have to change the sign and flip this last one. So you always flip the one that comes after the division. So before you can do the problem, you actually have to rewrite it. The first two terms can stay the same. But the last term has to flip. Okay, so I'm going to start by factoring the pieces. I see x squared minus 9 is dots, x plus 3, x minus 3. I see this is a GCF of x. I see this is a GCF as x as well. I see this is add multiply, which is x minus 4 and x minus 4. And I see this is add multiply, which becomes x minus 4 and x plus 3. So now this becomes the game of multiplication and crossing things off. If you feel more comfortable, you can rewrite it as one big fraction and write all of these terms over all of those. So we can make this x plus 3, x minus 3 times x, 5 minus x, x minus 4 times x minus 4, all being multiplied, of course, x minus 5 times x minus 4, x plus 3 times x minus 4. Okay, so now I'm going to cross off any top with any bottom. So the x plus 3's, the x minus 4's, the x minus 4's here, this x with this x, and this x minus 5 and 5 minus x, remember, cancels to a negative 1. So I have a negative 1 on top and an x minus 3 on top, and it looks like I've got nothing left on the bottom, so my final answer is negative 1 times x minus 3. Okay, the last example. I'd like for you to try to do this problem on your own. So for number 2, I'm going to ask that you do this for homework. And remember, we're talking about a rectangular prism in this case. So a volume of a rectangular prism. You may need to look up a formula for that. So volume equals what? And then you can figure out how to do it. Okay, jot down any questions that you might have, and we'll see you in class tomorrow.